Hello class, welcome to this lesson on solving for variables. I would like to remind all of you to set up your notes in the Cornell note style with a section on the left hand side for a summary and a section on the left hand side for questions and a section on the bottom side for a summary. So what we're going to do here is we're going to solve for variables. What does that mean? Well, let's contrast that with something else. Let's go to a basic algebra equation. Y equals x squared plus 3. And the question says solve for x. Solve for x. Well, in solving for x, I'm sure many of you already know that you need to subtract 3 from both sides. So we get y minus 3 equals x squared. And in order to fully solve for x, we would have to square root both sides. So our final answer is the square root of y minus 3 equals x. And what typically happens in a lot of math problems, we plug in a number for y. So we get, what if y equals 19? Okay, so we plug 19 in for y. 19 minus 3 equals x. The square root of 19 minus 3. And then so we have the square root of 16 equals x, and we get our final answer as x equals 4. So for a long time, many of you have been taught through your math classes to solve and find a number as your final answer. So I'm going to say that again. You solve and you get a number for your final answer. And there's nothing wrong with that. But about half of the time in this course, we are going to just solve for variables, meaning our final answer is going to be this. We are not going to plug in any numbers to simplify this any further. So we are actually solving and getting an equation as our answer. So let's take a couple examples of how this looks in physics. So let's look at a regular equation here that we are going to use. T equals 2 pi square root of m over k. So this is a formula that we are going to use. T stands for, this is time period. M stands for mass, and K stands for spring constant. I don't expect you to memorize this yet. I'm going to say it again. I don't expect you to memorize this yet. I don't even expect you to recall it right away. But this is an equation we will use in the future. So the question is, or the statement is, solve for K. So we need to get K by itself. So let's solve for K using our basic algebra skills. I'm going to rewrite it again down here because it's a little messy up there. So in solving for K, we need to get K by itself. That means we need to get rid of the 2 pi, the square root, and the mass. So in order to get rid of 2 pi, we divide both sides by 2 pi. And now we get T over 2 pi equals the square root of m over k. Next thing, let's get rid of that square root. In order to get rid of a square root, we have to square both sides. So now we have T over 2 pi squared equals m over k. Now, one thing we need to realize here, in doing this, K is in the denominator, and we do not want that in the denominator. We want in the numerator. And because we have two fractions set up right here, we can simply flip those. So we're going to flip this around. 2 pi over t squared equals k over m. And finally, we need to get rid of this m, so let's multiply m by both sides. So our final answer, this cancels out, m times 2 pi over t squared equals k. So this right here is our final answer. We solved for k, we got it by itself, we made sure it was in the numerator in the equation, and we got all the other variables on the other side. So once again, we didn't plug in any numbers into m or into t. and we're not finding a number right now. We are just solving for k. So this is a good example of solving for variables. I will do one more. So let's go to the back side here. Oh, I forgot to set up my page here. Let's do this. Let's set up real quick, Cornell Notes style. Quick reminder. And do one more. Here's another equation for you. Pressure equals the initial pressure plus rho g h. Now once again, this is an equation we will use in our class. I don't expect you to know what this is yet, but just know this is an equation we will use. I want you to solve for h. Solve for h. So, in order to solve for h, we need to get rid of this initial pressure and then the rho and the g. So, let's minus the initial pressure from both sides. Now we're left with pressure minus initial pressure equals rho gh, and then we are going to divide both sides by rho g. And our final answer is going to be pressure minus initial pressure over rho g equals h. So that is your lesson on solving for variables. To recap that, we need to, let's go down to our summary here. We need to make sure all variables are on the opposite side of the equal sign compared to the variable we are solving for. Once again, I want to emphasize this. About half of the problems you do in this class are going to be solving for variables. So if you don't like this, you need to get used to it. Because a lot of students don't like this. We are used to finding a number. We are used to finding a number, and now we're finding variables. And not only that, we are getting away from the traditional x, y solving for everything. That's what we do in math class. Typically everything is x or y, and sometimes we throw in z. Now I know that in calculus we get a little more than that, but right now we are going to have a lot of variables. As you can see, I've given you a lot in this lesson already. Pressure, gravity, rho, k, m, 2 pi, capital T. So you need to get comfortable with solving for variables because it is going to encompass a large part of this course. Thank you.